Okay, everybody. So we will go ahead and get started. What we're going to be looking at today is section 10.3 in your book. This is polar coordinates. So this is going to be, I don't know, maybe a little bit of a break from some of the difficult stuff we've been doing recently. Um, yeah, so this should go pretty well. It's not too bad. So let's go ahead and talk about it. So what are polar coordinates? Okay, so in the past, you made graphs before and you plotted points, right? So you plotted um, points in Cartesian form. You have plotted many points in your life, maybe not in this class, um, that are in Cartesian form. So what's Cartesian form? So what Cartesian form is x comma y. So that's why I say you've done a lot of it. You're pretty familiar with that, right? Like example, plot 3 comma 2, right? In Cartesian, I'll say it slightly differently. I'll say on the Cartesian plane. What's the Cartesian plane? That's just the xy plane. So that's the normal way that you plotted points, uh, probably thus far in your life. Okay. So if we wanted to plot 3 comma 2, of course, that'd be very easy for us to do. You would just go 1, 2, 3, 1, 2, and you would just put a dot right there. And there's your point, right? 3 comma 2. As easy as that. Okay. And so what polar coordinates are is going to be a way to plot points on a plane, but the coordinates are not going to be x and y, they're going to be something else. So polar coordinates. So what they are is uh, a system for plotting points or describing points on a 2D plane. A point's location, I'll say, on a 2D plane that uses ugh, that uses um, an angle theta and a radius. Actually, no, it's not really it's a radius, but not really a radius. It's a distance r. Right. So even though I listed theta first and r second, we actually list the points as r theta. So we use r theta instead of xy. That's the difference. Okay. So it's just going to be another system of doing the same thing. So why do we care? Well, it just makes it more convenient to plot certain kinds of stuff. Okay. Um, let's define this a little bit better though. So let's see here. What does it say? So theta, I'll get a different color here. Theta is going to be an angle measured in radians. So we're in radians. We're not going to be using degrees. So measured in radians. And it's going to be standard position. So this is the way that we've been measuring angles on the unit circle all semester. So that's fine. And then R is going to be a distance um, in or from the origin. So a distance from the origin. And so the units there are just going to be whatever the units are. So let's go ahead and plot a point, and then I think you'll be able to see a lot better what we're talking about once we do that. So here's an example of plotting a point in polar coordinate. So let's do this. Plot the point r theta equals 2 comma pi over 4. Okay, so this is what we want to do. Now, when we're going to be plotting this, we don't use a plane like this, labeled, X here and Y here. That's not what we use. We want a type of plot that's going to be easier to plot a point in polar coordinate. So we kind of use like kind of special graph paper. And I'll draw one. I've got one that I can just copy paste here, but I want to just kind of draw you one first before we do that, so I can explain a little bit. So here's the idea. So I'm looking at a blank set of axes here, right? And if this was a regular XY plane, you'd come out here and this would be 1, and this would be 2, and this would be 3, right? And same thing vertically, this would be 1, this would be 2, this would be 3. And if we were going to be doing what? If we were going to be doing an XY plane, then over on this side, these would be negative numbers, right? Well, not in polar coordinates. And you'll see why momentarily. Same thing down here. These are not negative either. These are just all going to be positive numbers. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So, why would that be the case? Well, the reason that would be the case is because, let me get a different color here. The reason that would be the case is because we're going to be measuring distances from the center. So, like if you've got the origin right here at the center, right? Maybe that was hard to see, but I just put a dot at 0, 0. All of the points that are a distance of 1 away from the center, they just make a circle like this, right? Those are all the points that are a distance 1 away from the origin. And if you wanted to look at the distance, all the points distance 2 away from the origin, that would look like this. And if you wanted to look at all of the points distance 3 away from the origin, well, that was unexpected. I will try better because I wasn't smooth enough. But it's too big of a circle. It's hard. Okay. So you get a graph like this, or rather, you get graph paper like this. And then on this graph paper, you have your angles, and your angles are all just measured in, they're from, words hard, sorry. All of your angles here are just measured in standard position. So like this angle is 0. And of course, this one up here is pi over 2. And over here is pi. Down here is 3 pi over 2. And if you went all the way around, 2 pi would be back here. But we don't really need to go to 2 pi. We just need to go to, well, up to 2 pi, but not including 2 pi, really. You can, but you don't need it. Anyway, so this is what your graph paper looks like. And then you have all of the other angles are on here too, although they're not labeled. So like, you can kind of, let me get a different color here. What would be easy to see? Right, like you'll have like a pi over 3 on there. No, that's not pi over 3. What am I doing? You have like a pi over 6 on there. You have like a pi over 4 on there. You got a pi over 3 on there, and so on, right? So you've got all the angles going around the circle. And that's what your graph paper looks like. Now, having done that, I'm just going to put in from my photo library here. Whoa, that's very big. It's not what I wanted. Make this smaller, and let's put this over here. All right, so this is what the graph paper looks like. I'm not sure that's better than the one that I drew, but there it is. So if you were trying to plot the point what you would do is you would simply find the angle here, right? So we got this angle, pi over 4. So where's the angle pi over 4? Of course, it's right there, right? Over here, it's over here. And then you've got the radius 2. So this is like your distance from 0 right here, right? Distance from 0. So you just find the angle pi over 2, and then you just move out from the center here in that direction by 2. So like if every circle is a distance of 1, right? So like if this is 1, and this is 2, and this is 3, and this is 4, and this is 5, and this is 6, right? We want to go out a distance of 2, but in the direction of pi over 4. So you're starting from the center here, and you go, okay, well, here's 1, here's 2. So this point right here, that's the point pi over 2 comma pi over 4. Let's put the same point on the other graph. So it would be like this, right? So you've got, this is a distance, this is all r equals 1. This is all r equals 2. The next circle is all r equals 3. Oh, oops. I marked this as 1, but this should have been 1, so I labeled all those points wrong. Should have been 1, 2, 3, 4, 5, 6, 7. And I could have labeled it differently if I wanted. I could have gone like 1/2, 1, 1.52, 2.53, something like that. But I did not. So here's our point. So this point is 2 comma pi over 4. Right, same thing here. This is 2 comma pi over 4. Does that make sense? So you've got an angle, theta, and you've got a distance from the origin. And that's how you plot points. So let's do another one. Oh yeah, so here's something. Well, no, we'll do these in order. Sorry about that. So let's do another example. Plot the following. We're going to plot 3 comma pi over 2. We're going to plot 2 comma pi over 3. We're going to plot negative 2 comma pi over 6. And we're also going to plot, let's see here, 3 comma negative pi over 6. We're not going to plot these all on the same graph. We're just going to plot them, get a couple graphs. All right, so let's do this. Do one of these. Drag it over here again. Come on. Okay. So there's one. We will make it smaller. Copy. Didn't work. How do I paste? What's the point of copying if you can't paste? Okay, paste. We got another one. Paste. Got a third one. Paste. Right. Good enough. All right, so we got 4 of these. Also, kind of feel like I want to mark these in. No, I don't. I lied. I was going to say I wanted to count them like 0.51, 1.52, but I don't really. We'll just plot them the way they are. All right, so on this one, we're going to plot the 3 comma pi over 2. So again, you find the angle pi over 2, right? So you got pi over 2, which of course is right here. And so we just need to go from the origin out 3 in the direction of pi over 2. So you just go 1, 2, 3 right here. So we're just going to put a dot right there. 1, 2, 3. There it is. 3 comma pi over 2. All right. And let's go to the next one. Over here, we're going to plot 2 comma pi over 3. So we need to find the angle pi over 3. Of course, you got pi over 3. Pi over 3 is right here. So we're going to head out 2 in that direction. So we're from the origin. So we're from here. So we go 1, 2 here, right? Distance of 2 away. So that's 2 comma pi over 3. Then we've got negative 2 pi over 6 is going to be our next one. All right, so we find pi over 6. Pi over 6 is right here. And now we've got kind of our first, not our first, but something a little bit unusual. We have that negative 2. So if you wanted to plot 2 comma pi over 6, we know what to do now there. 2 comma pi over 6, right? We got from the origin here, you would go 1, 2. So this would be 2 comma pi over 6, right? Where I've got the dot right now. So this would be 2 comma pi over 6. That is not the point that we want. We want negative 2 pi over 6. What could that mean? So you have to understand that when they give you a negative r, they actually mean instead of going towards the pi over 6, instead of going from 0 towards the pi over 6, you're actually going to head the opposite direction. So you'll move this way. So this is going to be positive r, going to move towards pi over 6. Negative r will move away. So it would be towards the 7 pi over 6 down here, right? 100 degrees away. Okay, so you have to understand. So we have to, with r equals negative 2, you move in the opposite direction from pi over 6. Okay, so it's not the one that we wrote there that we want. We want the opposite direction. So we want to go 1, 2 here. 1, 2 here. Okay. So that's actually the one we want. Okay, so we don't want this one at all because that would be positive 2 pi over 6, and we want negative 2 pi over 6. Okay. Now, what's the last point we want to plot here? 3 comma negative pi over 6. Let's do that. 3 comma negative pi over 6. And there's nothing really special about a negative angle. You just have to remember that we are counting these angles in standard position. So like positive angles go this way. Positive theta goes this way, and negative theta goes this way. Okay, ran out of room. But you get the idea, right? So if we want to plot negative pi over 6, then we're going to be going in the negative direction. So on this graph here, right? So 0 is here, and then we're counting by 12s on this graph paper. So it goes pi over 12, pi over 6. So it's 2 notches up, right? So if we're going negative pi over 6, instead of going 1, 2 up, we would go 1, 2 down. So it would be this 11 pi over 6 is what you would want. Okay, so negative pi over 6 is going to be down here. And then we need to head how far in that direction? 3. So we're going to go from here, we're going to go 1, 2, 3. Going to be right here. Where 1, 2, 3, right here. All right, so you could have a negative r, or you could have a negative theta, and you have to know how to handle those cases. But other than that, they're not that hard to plot. especially on a computer where you would put a dot in the right place or that kind of thing. Not hard to plot though. Okay, so we looked at those. Now what we want to be able to do is we want to be able to figure out how to go back and forth between x and y and r and theta. And you're going to go, kind of the rules are going to be different. Like you do one thing to go to r and theta, and you do one thing to go back to x and y. Okay, so let's say something about that. So now conversion to and from polar Cartesian. All right. So we're going to, right, we have to do both of these, to and from. So we're going to start with polar to rectangular, which is also what your book sometimes refers to Cartesian. So these are also called rectangular. Okay. Um, so yeah, polar Cartesian, polar rectangular. All right. So let's see here. So here we're going to have some rules. So this is how you're going to do it. So you've got a little picture here, or rather, I'm going to draw a picture and then you'll have a picture. All right. So if you've got an r and a theta, we've got a point here in the xy plane, right? And that's going to be, it's either x comma y or r comma theta. It doesn't matter. It's the same point either way, right? No matter how you label it. But the way you measure it is different. So if you make a line from here to here, then this distance is r, right? The distance from 0, 0 up to that point. And then you've got the angle theta is right here. That's where you have the angle theta, right? But you've also got x and y coordinates. So where are the x and y coordinates here? So if you kind of just make this line here, why didn't that go straight? I don't know. You have that and you have that. Then on this picture, of course, this distance is y and this distance is x, like that. Okay, so that picture has x and y and r and theta, and they're related using trigonometry, right? Because that right there is a right triangle that I drew. And we know, I don't like this color in this switch. We know from trig that if you have a sine and a cosine here, if I had the cosine of theta and I have the sine of theta, I don't know why I did cosine first. What would the cosine of theta be according to this picture, right? You know that in general, the cosine from triangles is the adjacent side over the hypotenuse, right? And what would that be here? So if this is your theta, the adjacent side is x and the hypotenuse is r. So x divided by r. That's your cosine theta. And your sine theta, is normally the opposite side over the hypotenuse. And so if this is your theta, opposite side is y, hypotenuse is r. So you have y over r, right? But this can be rearranged because you can take this and you can say, so we know if you just basically solve the equations for x and for y there, right? If you've got cosine theta is x over r, you can take this r, move it up to the other side, and you could have it say that x is equal to r cosine theta and y is equal to r sine theta, like that. And so you just use these equations, and that's how you would convert from polar to Cartesian. Okay, so you just use these two equations. So to convert polar r comma theta to, I'm going to say rectangular if I can remember, rectangular xy, you just put in the r and the theta into those equations right there. Substitute in the numbers for r and theta. Right? So that is your method for converting from polar to rectangular. Let me just highlight this, make it easier to find if you're looking. All right? Okay, so that's it. So let's just try a couple examples here. Example. Convert, or sorry, let's just say write the polar coordinates 3 comma pi over 2 as a rectangular coordinate. All right. Now, I don't even know if I should do this the right way first, or if I should just give you the punchline here, or a punchline here. Like, here's the thing. Pi over 2 is your angle, right? And you know that this is 0 and pi over 2 is straight up. And so if you were going to plot a radius of 3, r equals 3 in the direction pi over 2, that'd be really easy to plot, right? It'd be 1, 2, 3. It'd just be right here. And you could probably just figure out what the x and the y coordinates are right there, right? Could you? Like, what are they in x and y? Isn't that just an x value of 0 and a y value of 3? It is, right? So you could actually do that problem without even using those formulas. But like I said, I probably should not even have done that. I should have probably just used the formula. So let's use the formula anyway. Um, let's see. Use the formula, right? So what do? You have x equals r cosine theta according to the formula, and then you simply put in your numbers. So we know that your r is 3 and your theta is pi over 2. So you have 3 cosine pi over 2 like that. And so this right here, you just make sure your calculator is in radian mode. Let me actually grab a calculator. All right. So you have 3 cosine pi over 2. Make sure your calculator is in the correct mode. Otherwise, you'll be in trouble. And then you just type in 3 times cosine pi over 2. And when you do that, you're going to get 0 because the cosine of pi over 2 is 0. So this is just going to work out to be 0. So calculator, or like Wolfram Alpha or something, in radian mode. All right, so we have 0. And then for your y value, same thing. Y is r sine theta, which is going to be 3 sine of pi over 2. So again, you punch that into a calculator or something like that. Sine of pi over 2 is 1. So you're going to end up with 3 here. So if you want to write x comma y, it's going to be 0 comma 3, according to the formula there. So if you think about it, you could have figured it out because it was a particularly simple problem, or you can use the formulas and you just get the numbers right away. Okay, let's do another one. What's the next one here? Why are these so stupid? Okay, here we go. Convert. I'm just going to say r theta equals -1 comma 2 pi over 3 to rectangular. All right, and you know, I'm gonna plot this first. This is not required. You don't need to plot this point in order to do this problem, but I just am anyway. All right, so where would this point be? Let's just think about it. So first you'd have to find 2 pi over 3. That's not that hard, right? You just go around the unit circle. Here's 2 pi over 3, right? We got it right there. 2 pi over 3, 2 pi over 3. And this is -1 in that direction. So -1 means actually it's not in that direction. It's the opposite direction. So -1 in that direction is going to be here, right? The opposite direction from 2 pi over 3. Did I get that right? There's too many lines on this graph. It makes it hard to tell if you got it. But I think that's where it is. So it's actually down there in the fourth quadrant instead of the second quadrant. Now, did you have to know that in order to do the problem? No, you didn't actually have to do that, but we can find this point anyway, and let us do so. So let's use the formula. So what we're going to have is we're going to use the formulas again, which is the x value should be r cosine theta. You fill in your numbers. So your r is -1. And then you have cosine theta. Theta is 2 pi over 3. Make sure you use a calculator or Wolfram Alpha. That will give you an exact answer. So I've got -1 times cosine 2 times pi divided by 3. This comes up to +1/2 for your x value. And your y value is r sine theta, which is, again, -1 for r. Sine theta, the theta is still 2 pi over 3. We have -1 times sine 2 times pi over 3. And we get, what? Oh, okay, I typed that in wrong, sorry. Negative sine times pi over 3. Negative square root 3 over 2. And if you want to know what that is as a decimal, that's approximately -0.866. Okay, now you do want this in exact mode, like you want an exact answer unless the problem says to round, right? So I've got 1/2 and I've got negative square root 3 over 2. That's the right answer, right? So the point is actually the xy coordinates are 1/2 comma negative square root 3 over 2. Okay. Not, you wouldn't want to put the decimal unless they say 2. And so if you plotted that on a little xy plane, right? So like if I go like 2 boxes is a half, so like that's 0.5, that's 1. That's a negative 0.5, -1, because we're in the xy plane now. Then this would be +1/2, and then negative approximately 0.866. So down here. So it's approximately like this. 1/2 negative square root 3 over 2. And of course, that's what you have here as well. It's just kind of, small here because it's 1, 2, 3, 4. So like from here to here is 1, and here to here is 1, here to here is 1. So, we got the point down there. That's what was important. And so that's how you convert from polar to rectangular. And you can do this in like on Wolfram Alpha or something. Actually, you can do it a lot of ways on Wolfram Alpha. You could probably say convert parentheses. What was it? -1 comma 2 pi over 3 to, I'll say rectangular just to see what it says. It might, I think it's smart enough to know. Yeah, see, it did know that I was talking about polar, even though I didn't say polar. But you see, it did it, and you see it's got the answer, and then you see it's got a picture. They're just showing you that it's in the fourth quadrant there. All right, so you can do that. Or you can simply, you could type it in this way. You can go negative cosine 2 pi over 3 parentheses, comma, and then negative sine. The negative was for the -1. 2 pi over 3 for x and for y, parentheses, parentheses, return. So I can just type it in that way. And, there it is. Also, it tells me what they are in exact form down there. And then there's my picture. So you see it's all consistent, right? Everything we've done agrees with itself here. All right, so let me open Notability. I have to close Notability now. Hold on. Okay. Yeah, okay, we're good. So that's how you convert from polar to Cartesian. That's the easy direction, though. So now what we have to do is we have to talk about how to go back the other way. We have to go back from rectangular to polar. A little bit harder. Oops. Rectangular xy to polar r theta. Okay. And so the picture, again, that is our guide here, is that same picture that we had before, where you've got a point there, and that's called x comma y, or it's called r theta, depending on what you're calling it. And we got this line, and we got this line. We've got a right angle, and we got a theta. We have an x, and we have a y, and we have an r. Everything on there. Okay. And so we know from before that we had this, right? We know already that the cosine was, sorry, give me a second here. Oh, they just wrote something that made no sense at all. Weird. I think they just have a typo. So what we know is this. So we know that we already had that x was r cosine theta, and we had that y was r sine theta. Now the problem with these equations for converting, two polar coordinates is you can't really solve this for theta very well. It's not that easy to solve for theta. And so even though we have these equations and they're still valid, this is not, the ones that I just wrote there are not the ones you want to use. There's a trick to this, okay? So the first thing is this, but if you compute y over x using these formulas here, so y is our sine theta, x is our cosine theta, you get, what do you get? You get r sine theta over r cosine theta, right? Just substituting in what y and x are. But the reason you want to do this is because you can see that there's an r on the top and an r on the bottom. It means you can cancel the r, which means you're left with just a sine over a cosine, and a sine over a cosine is a tangent. Okay, so what we can have is that the tangent of theta is equal to y over x. Okay, so that's one of the equations you need. Now, why do you want this one instead of what we have up here? The reason you want this one is because this has theta, but it does not have r, whereas this has r and theta. So if you don't know r and theta, how could you, if you only know x, this is not going to let you find r or theta because there's two variables in here, right? There's three total variables, x, r, theta. So you would have to know two out of the three. You won't. But here you have three variables, but you're going to have the x and the y because that's what you're starting with. So there's only one unknown variable, and you'll be able to find it. Okay, so that's why this equation is preferable to these. This one's actually solvable, mostly. Okay, so we're going to want that one, the tangent theta y over x. But another one that we're going to use is how to get the r. And the way you do that is you apply the Pythagorean theorem to this triangle. So you know the Pythagorean theorem, like a squared plus b squared equals c squared. You've probably been doing that a lot in the sine and law of sines and law of cosines section. Maybe you have. Depends on the problem. But you've been doing similar things. But what am I saying? Pythagorean theorem. A squared plus b squared equals c squared. This is your a, this is your b, this is your c. So what you get is that, I'll write it up here first. X squared plus y squared equals r squared. You get that. But if you're trying to solve that for r, you can take the square root. And you would get r is the square root of x squared plus y squared. Okay, so those are the two equations that you want. But actually using them is a little bit tricky. And the reason using them is a little bit tricky is because when you get the theta, you are actually, you're going to get an answer that's between negative pi over 2 and positive pi over 2, and you're going to have to use, like, what's it called? You're going to have to use which quadrant the tangent is positive and negative in, or sorry, yeah, you're going to have to use extra information to get the theta. It's a little bit trickier than it seems. Let me just box this and we'll do some and you'll see what I mean. All right, so these are the equations that you want. That much is true. So you don't care about the ones that I wrote outside this box here. Okay, so you can get r easily. So one. It's just kind of a note here. It's easy to get r. R. Okay, so there's no issues. Just substitute in the x and the y. So plug in your x and y. But for the theta, what you're going to have to do is you're going to have to use knowledge of the sign of the tangent in each quadrant and what quadrant you're supposed to be in. Okay. When you find theta, so it would be theta is going to be tangent inverse. You might actually have to, adjust it to be the correct quadrant. Let me see how they say it. I want to say that you just need to add or subtract pi in order to do that. Trying to think if that's correct. Yeah, it is. to get the quadrant correct. All right, and what was this? This was instructions for rectangular to polar. All right, so enough of that. Let's actually do a problem here. So, all right, let's go. Here's the first one they have. Example. Convert, was it xy equals 3, 3 into polar. All right. So you have to pay attention, what you're converting from and what you're converting to, because the rules are different. And let's see here. Of course, we know what 3, 3 looks like. It's right here. This is 3, 3. At least that's it in Cartesian, like that. Okay. Now we want it in polar. So what you'll do is you'll kind of follow these rules here. So we're going to compute the r first. So we're going to use r equals square root x squared plus y squared. That's how we're going to calculate the r. So we go r equals square root 3 squared plus 3 squared. So that's going to be the square root of 18. And you can simplify that. I am just going to type it into my calculator because my calculator will simplify it for me. I'm not going to do that by hand because I'm lazy. 3 square root 2. You can use Wolfram Alpha for that, right? You come here. Square root 18. Right? And 3 square root 2. So if you need it simplified, it's easy enough to do. Just type it into Wolfram Alpha or similar. That's not what I want. This is what I want. Okay, it did screw up. Hold on. I need to close it. Come on. All right. Here we go. Okay, back. All right, so that's how you get the r. Just use that formula. Now for the theta, that's the one that I said was hard. In this case, it's going to be easy though. So I'm using theta, and it's just going to be tangent inverse y over x. So you go theta equals tangent inverse y over x, so 3 over 3. That's what you need to calculate. Again, you can use a calculator if you're in degree mode, but you can use Wolfram Alpha as well. So I'm just going to use my calculator here. So you have inverse tangent 3 over 3, which is 1. So inverse tangent of 1. And it tells me that theta is pi over 4. And that's good because that is actually this angle, right? Like that angle is pi over 4. So we're fine, right? So since theta equals pi over 4 is quadrant 1, and we know 3, 3 is quadrant 1, theta equals pi over 4 is correct. Right? So I'm just doing a little bit of thinking there. So our r theta is going to be, what's the r? 3 square root 2. What's our theta? Pi over 4. That is my answer. Okay. That's my answer. And of course, that makes sense. If you graph it this way as well. Get a small thing here. So if I put my points like this, because I just made the graph small here. So if I call this 1 and this 2 and this 3 here, actually, no, that won't work. So dumb. 1, 2, 3, 4, 5, 6, 7. All right. So how big is 3 square root 2? 3 times square root 2, 4.24. So if you find the angle pi over 4, which is right here, and you head out a distance of 4.24, then we got 4 boxes. So we got 1 box, 2 box, 2 box, 3 box. Terrible things have happened. What did just happen? Okay, we're back. Undo. So you have 1, 2, 3, 4, and then a quarter. So it's about right here. So that point is about right here. And that makes sense. 3 square root 2 pi over 4. That seems to agree with, of course, this picture up here, right? 3 comma 3. So it's like 3 over 3 up. But that's not how we plotted it, because we plotted it down there in polar. Okay, so that was easy enough. Okay, but what we need to do is we need to do this in a more complicated problem here. Let's see here. Convert polar to Cartesian. Nope. Convert Cartesian to polar. Yes. Okay. So 3, 4, 6. Yeah, that's good. We'll do this one. Convert. This is going to be xy. And it's -4 comma 6 to polar. That says polar. Polar. Okay. So that's what we want to do. So we know what this looks like on a rectangular graph, of course. Right? We got like -4 over there, and then you got like +6 up here. So we got -4 comma 6. Okay. And what quadrant is that? Right? That's going to be quadrant 2, right? Because you got 1 here, 2 here, 3 here, 4 here. Okay, so that's quadrant 2. Now just remember that for the moment. So let's go ahead and let us, try to find these coordinates. So we're going to use r equals square root x squared plus y squared to get the r. So we just substitute in the x and the y. That's easy. -4 parentheses squared plus 6 squared. So it's going to be square root. 4 squared is 16. 6 squared is 36. So what do we get? What is that? Square root 52, I guess. Yeah. Square root 52, I think. Is that right? I hope. Or 2 square root 13, as my calculator says. Okay. So you do that, you've got the r. Now we need to get the theta. So for theta, you're going to use, theta is going to be the tangent inverse of y over x. I'm going to do it on Wolfram just because. So we have 6 and -4. I'll try to remember that. Y equals 6. X is -4. 6, -4. Okay. So we go Wolfram Alpha, just in case you don't have a calculator that's good at this. So you can just say, you could say for tan inverse, you could either say arctan, probably how you want to do it. And it's y over x, which was 6 over -4 or -4 over 6. I don't remember, but it doesn't matter. It's going to be the same thing, right? So you do that. Wait, is that correct? Give me a second here. Okay, yeah, that's fine. I don't know what I was doing. I was having a brain fart there. Um, okay, so you do that. Um, it's not a good it's not a good number here. Um, so it's like negative 0.98. Huh? Okay. Negative 0.98. 0.983. Okay. Now, here's the thing though, is if you look at the angles on this graph here, we get the coordinates back up. Here's the thing. If you look at where negative 0.983 is, um, it would be where? So like this is 0, of course. Now down here, this is down here, this is 3 pi over 2. But 3 pi over 2 is, if you calculate it, or sorry, 3 pi over 2 is also negative pi over 2, right? Because you have positive pi over 2 up here. Negative pi over 2 is the opposite direction. So that's positive, remember, and that's negative. Um, so we've got negative 0.983 here. But I've got that negative pi over 2 that's on the bottom. And if I just punch that into a calculator, like how big is pi over 2? It's about 1.5, right? So this is approximately negative 1.57. Okay. So if you wanted to figure out where negative 0.98 is, well, 0 is here, negative 1.5 is down here. So negative 1 is somewhere in here, right? So it's somewhere down here. It's hard to get it exactly right. Uh, but it's like somewhere in this range. Somewhere in this range is where negative 0.983 is, right? Because you got 0 here and negative 1.5 here. So it's in between and it's about there. Okay. So that's where that theta is about there. But that's in quadrant 4, right? This is in quadrant 4. Right? In quadrant 4. Well, that can't be the right angle. That's not the right angle because what we actually want is in quadrant 2. So we wanted this angle up here, but instead of this angle, we got the one down here, right? So we ended up with this one, which is the wrong one. So what you have to do is figure out to say like, okay, well, this is the wrong one. The correct one is up here somewhere. So how are you going to get this one up here? And so the answer is you just need to add 180 degrees. To get from here to here, you just add 180 degrees. 180 degrees is pi. So since this is the wrong angle, right? This is in quadrant 4, but we need it in quadrant 2. So you just add 180 degrees, which is pi. So just add pi to move it 180 degrees. Okay. So when we do that, it's going to go from here all the way around to here when you add pi. And then that's how we're going to get the um, correct angle there. So it'll be like around here. So this is going to be the correct theta. All right. So the moral of the story there is really like that was more complicated than I made it sound. Um, so it's just simple. If you get the angle in the wrong coordinate or in the wrong quadrant, just add pi, and then that will move it to where you want it. Okay. So the correct angle is actually this one. So theta is going to be the negative 0.983, and then you add pi, and then that's going to be the correct one. So I'm just going to grab my calculator. I'm going to redo that tangent inverse. Tangent inverse, 6 over negative 4. There it is. And then I'm just going to write plus pi. And I'm going to get 2.158. Okay. And that is going to be in quadrant 2, because remember, this is pi over 2, which is about 1.5. Right? We just did that down here. So this is about 1.5. This is pi, which is about 3. So 1.5 and 3. So what's this? About 2. So it's all consistent, right? So what do we get? We get final answer is r theta is going to be the r we calculated to be 2 square root 13. And with some work, the theta was approximately 2.158. And that would be my answer. So the moral of the story there was if theta comes up in the wrong quadrant, add pi, and it'll be the correct one. I think that'll be correct, because what'll happen is if it's down here, adding pi will make it positive, which is generally what you're going to want. And if you get one up here that's actually supposed to be in quadrant 3, then again, adding pi will make that happen. So there's no subtracting pi you have to worry about. So you don't have to worry about negative positives, really. You just have to add pi, and that will fix it. So if theta comes up in the wrong quadrant, add pi to get the correct theta. And that's kind of the key to doing that. Okay. So that was an hour and 2 minutes. Very long here. Let me see if I can do another one of these. We'll do one more, and we'll do it much faster because we'll just do it rather than explain lots of stuff. So let's do another one that's going to be probably equally hard. So let's convert xy equals 3 comma negative 5 to polar. Okay, so we're not going to draw a bunch of pictures, really. I said that right before I draw a picture, but we're just going to at least notice that the 3 comma negative 5 is going to be like 3, and then like negative 5 is down here. So this is the kind of point that we have, right? So it's in quadrant 3. All right, so let's go ahead and get started. So we're going to compute the r. R is square root x squared plus y squared. Put in your numbers. 3 squared plus, careful with parentheses, calculate that. So we got square root 9 plus 25, which is going to be square root 34, which is going to be what? Does that simplify? No, it's just square root 34. So that's easy enough. Then the next thing you need to do is compute the theta. So you go theta equals tan inverse negative 5 over 3. Again, make sure you're in radian mode. I'm going to punch this into my calculator. Tan inverse negative 5 over 3 y over x. I get, wait a second. That's not what I wanted. Okay, you know what? I'm backing this all up because I want. uh, how many people there are really frustrated with me, been saying you're wrong the entire time? Let me do this. I wanted, like, the point that I drew is the point that I wanted, but the point that would have been -3, right? And then -5. -3, -5. That's what I wanted. Sorry. -3, -5. Okay. So let's talk through this. -3, -5 is the point that I wanted. That is -3, -5. So that's the point that I drew. Now let's go through and calculate it. So -3, -5, both negative, both negative. Okay. So again, you're going to calculate r first. So -3 squared, -5 squared. This is going to work out the same. That's still going to be square root 34. Okay. Now for the theta is going to be tangent inverse y over x, which is -5 over -3. I have an extra negative sign now. You calculate that, 5 over 3, and you get, again, it's not a good number. It's just a number, approximately 1.03. Okay, approximately 1.03. Now, when you figure out where that would be, again, remember in your polar coordinates graph, right? Theta is here, pi over 2 is here. Well, pi over 2 is approximately 1.57. You have pi here, which was approximately 3.14. And then, and so on. Down here, you got 3 pi over 2, which I don't know how big that is, but we can figure it out. 4.71. Okay. And then, this would be like 6.28 or something. 2 pi. All right. So what's the point? The point is that you get this angle, 1.03, which is in between 0 and 1.57 again. So it's up here somewhere, right? So you get this angle. You get an angle up here. And that's wrong, because we actually know that it's supposed to be down here in quadrant 3. So you get this angle, you realize that that's in quadrant 1, which is wrong. What do you do if you get it in the wrong quadrant? We should just be able to add pi, because we actually just want the one that is 180 degrees away from it down here. Okay, so you just add pi. And we're actually going to get theta is not that. It's going to be the 1.03 plus pi. So you get out a calculator. And it is 4.17, approximately, right? I rounded. So what's my answer? My coordinates in r and theta are square root 34 and 4.17. And I could have, got a decimal answer for that square root 34. I just did not. Okay, so hopefully that makes sense. You can see that it is harder to go in that direction. XY to r theta is harder than r theta to xy. That's just how it is. But yeah, so we're not done with this topic. We're going to have one more lecture on this week. But that's enough for now. We're an hour and 10 minutes in. So talk to you next time.